Bismillahirrahmanirrahim. Today is an introductory lecture of our channel, A Programmer's Approach, also abbreviated as APA. In this introductory channel, I will explain the purpose of this channel, our intentions to deliver the lectures, motivation for this channel. Let's move on. The motivation is based on following factors. As you can see on the slide, the idea behind starting this APA channel comes from my personal experience of 15 to 20 years in academia and some years in industry. I have been there in these two areas as a student and as an instructor at different levels, at the UG level and at the PG level, which is master's and PhD level. I've also trained people in academia and industry from these levels. So I have a good idea about the students' feelings and the instructors' feelings when they face the difficulty in delivering the lectures and giving the knowledge of programming languages to the students. Broadly speaking, we can make two groups of people in computer science. One group of people, they are strong in software engineering principles. They are software engineers. They are good at documentation, design, following the processes, following the methods, whereas the other group is strong at software development, at the programming. Some people are good at both. They are the people who actually move up the ladder in the hierarchy of software development team. The people in the software engineer group, they avoid programming, and the people in the programming group, they avoid documentation, following the processes, design and architecture, these sort of things. The purpose of this training is to give you a programmer's approach to learn everything. There are people in industry who actually started their career with, after high school, a simple one short semester course of a programming language, and they entered in the industry as a programmer, and they have learned the software engineering principles by experience, and they have moved up in the hierarchy of software development team with their quick learning abilities. So software engineering is necessary, but without the program development, without the software development, without the programming, one cannot be a good skillful engineer. So the purpose of these slides and this series of lectures is to make short courses, short recordings, short lectures of 5 to 10 minutes, which is easy for the learner to remember and to understand. The language, who will benefit and how can one benefit? The language of the slide is English, recording is in English, and in Urdu I will record two lectures, one in English, one in my native language Urdu, which will be bilingual, Urdu plus English. Technical level of these lectures will be for everyone, starting from the very basic and gradually, slowly moving up. But every lecture will be very short, not very long, not very detailed. Details can come later when it is necessary, when my audience is ready to take the details. The duration will be 5 to 10 minutes, sometimes few minutes up, few minutes down. Easy to memorize, no extra effort would be required by the audience, by the people, by the trainers to memorize the things. They can learn, practice, and remember naturally. The programming language is necessary, of course, a programmer's approach. Any programming language can fulfill the purpose. A programmer, for me, a programmer of one language is the programmer of every language. All one has to do is to switch the language. To switch the language, all one has to do is to learn the syntax. The concepts, the fundamentals, the logic remains the same. In this slide, I'm trying to explain the concept of programming and the program. A program runs on a machine, on a hardware. With a useful program on a machine, on a hardware, makes it a useful device, a robot, an intelligent device, an intelligent machine, which can do a specific task for us. For example, the microwave, the washing machine, automatic washing machine, the wristwatch, the smartphones in our hands. If we take the software out, the hardware is useless. It's not an intelligent or smart device or machine anymore. It is just a hardware. Similar to a human being without the soul is just a body, useless body. Can't do anything. So the software is the main part. A software is a program. A program is written in a programming language. There are many programming languages. A program is a collection of 5 things, as it is being shown in this diagram. The 5 things are the input, the output, internal storage, external storage, the processing. Very simple example. If I ask you to prepare yourself for a mental math question, I will give you 2 numbers and I will give you operation then, and then you will give me the result. So after listening all this, whatever I've said, you have prepared your mind to keep the numbers in your head and listen the next part of the operation, then apply, and then give me the result. So for instance, if I say 2 numbers 5 and 6, I pause, you have kept the numbers in your mind. Now I speak of the operation addition. Now you apply the addition on the numbers and give me the result. So what is actually happening? The input is coming into your mind. You are holding some of the information. You are waiting for further information. Another part of the input comes in. You hold it in. You apply that part on the internal stored number, do the processing, and give me the output. Before I give you next mental task, you may like to note it down for your record. That what have you done in this small class, different tasks, you put it down in your notebook, and that would be an example of external storage. So every program, small or large, in any kind of device is actually can be depicted by this diagram. 5 things. Programming languages. There are many programming languages. Programming languages come and go. Many get popularity. Many get don't stay long in the market. But broadly speaking, we can categorize the programming languages into 3 categories: the machine language, the assembly language, and the high-level language. At the moment, the machine I'm using is a laptop with an Intel processor. So this Intel processor comes from a company. So that is a hardware device, hardware chip with its own specific language, which it understands. The machine only understands the language written in this form, 010110 in this form. That is called the machine language of the Intel processor. Every machine is the same kind. Obviously, this way of writing the program is not developer friendly. Developers can't remember, human being can't remember easily the sequence of 0 and 1 for different instruction and for the different numbers. For example, I asked you to apply addition operation on 2 numbers, which is shown here. So this is easier. In assembly language, it is easier to write this way. So to bearing in mind the ease of development and the speed of development, both, we have come up a better language, which is known as assembly language, which is of this form rather than this. Still, initially it was okay, but later on when we started realizing that the programs are getting bigger and complex, this still is not very user or developer friendly. Then we come up with high level languages. There's a long list of high level languages, which is more of like allowing us more natural way of writing expressions like mathematical expressions, for example, like this. So this is further user friendly, developer friendly. Obviously, languages have advanced so much these days that these days many of the languages don't even require, many of the environments don't require too much coding. We can write visual languages. For example, Blockly on the Google, I think it's a Google's language, Blockly. They do this, that you develop the program visually. For this series of lectures, we will select the Java language, and in the next lecture, we'll see why Java language. We'll stop this first introductory lecture here. If you like this, tell others. If you don't like, and if you have any feedback, you tell us. Thank you very much.